development and acting as a owner's representative and various other things there. And really kind of where I've landed now is the space in between architecture, construction, and development, helping various entities do actually a lot of projects like this, large scale, high performance buildings.
And I think what you'll see that Brandon and I have in common, really largely other than our voracious researching appetites and wanting to solve problems, is that we have a long-term approach to real estate development. And we have a focus on trying to build the best buildings that we can, durable buildings, quality buildings from the start. Hillandale Gateway, the project we're featuring and talking about here this evening, is actually a partnership. It's a partnership between the Duffie companies. The Duffie companies are a real estate development firm headquartered also in Montgomery County. I spent 17 years until January of this year running the business development, new development side of the Duffie companies. The Duffies are my family. It's my uncle and my cousins. I was hired by them 17 years ago, and over the years helped lead the Duffie companies into a focus on sustainability and high performance. But Duffie's a third generation business, commercial and multifamily owners, again, long-term holders focused on quality and durability. And we are fortunate, and PS Ventures now is partnered with the Duffie companies in partnership with HOC. HOC is the Housing Opportunities Commission of Montgomery County. It's a quasi-governmental agency. Its mission is to provide affordable housing and supportive services that enhance the lives of low and moderate income families and individuals in Montgomery County. They, of course, only work in Montgomery County, and we're really fortunate to have them as our partner. They are a developer, owner, and manager in their own right, and that gives them, again, that long-term perspective, and they appreciate and share the desire to build buildings well, durably, and with high quality from the start. So how did we get to Hillandale Gateway? As I mentioned, for many years, I was working with my family at the Duffie companies, and way back, probably even before 2006, we had a piece of property that had been subject to a ground lease in a prominent location in Hillandale that you'll see here in a moment. It had been subject to a ground lease, and the ground lease holder failed and gave the property back to the Duffies. And we had to decide what we were going to do with it. And we surveyed the landscape, listened to the market, and a lot of folks were, we had some of the typical users because of our prominence on the Capital Beltway. There were banks who wanted to go there with drive-throughs. There were restaurants, a lot of the typical fare. But we knew that at that time, the United States Food and Drug Administration was relocating to a headquarters 1 mile up the street in White Oak. And so we thought we would build a commercial office building in Hillandale. And for those of you that are not familiar with Hillandale, it's at the eastern edge of Montgomery County, Maryland, immediately adjacent to Prince George's County. And Hillandale has not been the beneficiary of as much investment as the western portions of our county had, and it was not the likely spot necessary to build what we chose to build, which is a speculative Class A office building. We built it because the headquarters for the Duffie family of companies was getting a little older. It was immediately adjacent to this building. We figured we'd build a building that would serve partly as a new corporate headquarters for the Duffie family of companies, and that we would lease out the remaining space in the building to other tenants, to other users. And with the U.S. Food and Drug Administration coming up the street, we figured we would get maybe a contractor or a pharmaceutical company who might locate with us. And as those of you recall, 2006 into 7 into 8, as we were finishing this project, was not a good time for commercial real estate. But we are heavily involved in the community, and I became aware through participation in a group that involved the FDA and GSA that they were outpacing their growth on the Federal Research Center up the street and would be out looking for commercial office space. In the meantime, as I was researching the options for how to build this building, I'd gone to my family and asked that we could build a green building. I had found LEED, and I came back. It seemed to make a lot of sense. I bring that up now because it's very much how I feel today about some of the other standards that we see. But I went to my family. I said, "Hey, we're going to build our corporate headquarters. We're going to have other users. Let's build a green building." And I was told, "No, we're not going to build a green building. It's going to cost too much money. Nobody cares about green buildings. Show me where there's green buildings and that people are leasing these green buildings." And ultimately, I was persistent and explained to my family that I thought that as long-term holders of real estate, this made a lot of sense to build a high-performance building for the reasons that most of you are probably familiar with. But the winning argument was ultimately that we were, as long-term holders, going to have leases that would expire in maybe 5 years or 10 years. And while LEED was not required in Montgomery County when we programmed and permitted this building, we had reason to believe, looking to California, that it was coming, just the way we look right now for what's coming down the pike today. And we said, do we want to be the first of the new generation of buildings or the last of the old generation of buildings? And that was the winning argument. And so we were fortunate. We built a LEED gold building, core and shell, speculative. We were rewarded with that decision ultimately as FDA outpaced its absorption in the Federal Research Center with a 10-year lease from the GSA for occupancy by FDA. That lease expired actually last year. We competed again. This building actually achieved Energy Star certification as well. And a decade after we built this building, we're proud that we also achieved Energy Star certification and ultimately won a second award starting last year for an additional 15 years. And with that, we were off to the races, off to the city of Frederick, built the city's first Energy Star certified homes, won Energy Star Partner of the Year for this building, achieved LEED for Homes Gold certification on all the units, came back down to Montgomery County, built the Duffie headquarters, triple platinum headquarters, platinum core and shell office, platinum commercial interiors for the Duffie headquarters fit out, and a core and shell retail building next door. We ultimately did tear down the old Duffie HQ and replaced it with our first hotel, my first foray into hospitality. Again, bringing my passion for high performance green building, building a LEED NC Platinum. We think this is 7th in the US and first flagged Platinum hotel, meaning we had to achieve this while accommodating the requests of, in our case, Hilton, but making it swim like every other Hilton Home2 Suites while still achieving this high level of certification. This is why PS Ventures does what we do. We believe in the triple bottom line, obviously not the inventors of this, but we believe that this is the best way to go forward and that we can build buildings that are good for the people, both the occupants and the communities in which the buildings are located, better for the planet, and we can do so profitably. We get asked most often, probably, how much more does this cost? We think that's actually the wrong question. The right question is really, is it worth it? Yes, there are items that have higher first cost, and we try to balance those with items with lower first cost so that we are trying to achieve this at parity. Everything you're seeing before you today for Hillandale, we're trying to build for a cost parity with what a traditional building would be. In answer to the question, it looks like anecdotally for us, the choices we make, it adds a little less than 5% to the initial cost, hard cost of the buildings to achieve the type of buildings that we're going to show today. But these are the reasons why we do what we do. And I won't spend too much time to go through all of them, but suffice to say that we have found success with their buildings because of a combination of all of these reasons. And each one waxes and wanes his importance as time goes by. And that brings us to Hillandale Gateway. Hillandale Gateway, again, a partnership between HOC and Duffie PS, prominently located on the Capital Beltway at the Maryland 650 New Hampshire Avenue exit. You see here in yellow are the holdings of the Duffie companies at the time of the partnership, and HOC had interest in Holly Hall, which is an older deeply affordable housing project immediately across New Hampshire Avenue from the holdings of the Duffie companies and family. And fortunately, with the advent and the coming of the Food and Drug Administration, Montgomery County went through a master planning process. They designated higher density zoning to certain areas that unlocked the potential of the Hillandale Gateway site for us to come through with what you see here, which is and I think we're actually going to achieve more like a 30% site-wide affordability target. Again, our partner is HOC, happy to have them. And that's, of course, their mission. We have a single phase program, 2 buildings, 155 units and 308 units. And you can see we're trying to target some pretty aggressive sustainability targets here. We're going to try to achieve LEED for homes. Platinum, we think homes versus NC is the correct flavor of LEED for multifamily buildings. Energy Star, multifamily, Passivhaus, and that's PHIUS, Passivhaus Institute US. And for the 155 unit building, we're going to try to achieve zero net energy on that building. The other building, so one building we refer to as the age restricted building, the other the non-age restricted building, connected by a parking structure, and there are actually a couple single story retail pads here in front. So our approach to this is to innovate through smart adaptation. Brandon and I enjoy doing lots of research, seeing what's being done, not only here in our local area or nationally, but internationally, and talking to a lot of people. We attend sessions just like this one to learn from folks who are trying and succeeding, or trying and I won't say failing, but trying and finding things that they would do differently so that we can learn from those experiences. We have a team pulling in the same direction. We work with an iterative process. We're really trying to keep it simple. Some of those tours towards some high performance buildings that relied on very complex systems. And in our experience, that's not a great recipe for long-term maintenance and success. So we're trying to keep it simple, and we look at cost as a value, not just a first cost. Brandon, do you want to kind of talk a little bit about our research and how it leads into Passivhaus?
Absolutely. So I will say I very kind of parallel path to Shane. Was actually the green building movement quite early. I joke I was actually raised in kind of one of the early low energy homes of the 70s, and then actually got my degree in environmental design and architecture, and then got into LEED quite early, about 2000, 2001, 2002, and very quickly became fairly frustrated because of its lack of attention on energy. That led me to a very similar path to Shane, which was to stumble across Passivhaus. I joke I was in Passivhaus so early, it was before the divorce occurred, when the German Institute and the US Institute were the one and the same. And I also joke I was on the West Coast at the time, so I missed the fact that the divorce had occurred. But what got me about Passivhaus was it was the first energy modeling software where the results aligned with the model. I had done a bunch of LEED projects, done DO2 modeling. I've even built my own for my own project. And once stumbled upon Passivhaus, really realized like the building physics behind it, the way the equations work, actually as close as you can in modeling, reflect outcome. And so next slide, kind of go through. I think as part of that, Shane and I eventually met through PHIUS. He attended a Passivhaus conference where someone else from our conference spoke. But I think he saw very much the same thing, that the future is heading towards a Passivhaus philosophy. And even over the last 5 to 10 years, just the amount of companies or large companies that are moving towards actually focusing on deep energy as necessary for either investment or ownership, or to comply with investors' actions, or as a method to address climate change. It doesn't really matter how you get into it. I think fundamentally the difference is the market is heading this way. because it provides better buildings. They're healthier, they're more durable, they're more sustainable, they're less energy intensive, they're more protective of the investment. That said, the US is a very, I hate to say, momentum-based construction industry, and the momentum unfortunately hasn't been in that way in the past, but it is rapidly heading that way. And there are every year larger and larger projects, almost exponentially growing in this space. And I think that belief that this is where the market is heading, I think Shane and Duffie and HOC saw the way. Unfortunately, with Montgomery County, it takes so long to actually entitle anything that the wave is going to probably catch up by the time this thing is built. But to their credit, they've really kind of invested in really figuring out how to do this at scale. I think zero energy, not to hop back one slide, but that was something else that really kind of became part of the project. Between tax credits available, the amount of space that there's available for solar, that was a really aspirational goal, even beyond Passivhaus from the beginning of the project. One of the things that made it possible was the necessity to actually have parking in a large site where we could deal with a garage. From my experience, we have really struggled to do anything net zero beyond about 4 to 5 stories. But because the amount of land, the project, and the program of the site, one of the goals very early on became to get the AR to be net zero. And as we have brought the solar consultant on, we're actually struggling to have enough, I hate to say, energy use on site to cover solar. So there's some debate now about even potentially moving some of that energy to other parts. So back to what is Passivhaus? We'll dive in kind of quick to that. Like I covered before, I view it as a building energy philosophy tied by a block. If you look at what the target is, 15 EUI is probably the easiest way to translate it to US terms. But really what's getting attacked is the heating, cooling, dehumidification loads, and then eventually you get onto hot water as well. I will say Passivhaus was a little bit late to addressing hot water as an issue, but I think over the last 5 years, it really has been a focus because they had already handled heating, cooling, ventilation loads, dehumidification loads to get them to be, sometimes 80 to 90% below a typical building and, 40, 50, 60, 70% below even Energy Star. Plug loads is always the biggest debate, meaning none of us can really control what people plug in. And as much as we start to do things to educate, that's the one realm that I think all of us who are in green and sustainable building, that's the last frontier or the next frontier. Next slide. Probably don't need to cover it for this building, but we do at least go through the high level philosophy, at least the 30-second pitch of what Passivhaus is. I still describe it as building a thermos. So you have continuous insulation, you minimize your structure coming through, you air seal it tight. So your goal is to keep as much energy on the inside of the building or the outside of the building and not have it bridge. That said, we all need fresh air. So the passive of the Passivhaus comes from the ERV or HRV, the ventilation system. And the idea of passive came because it was a passive exchange of energy. It's not passive solar. It was a way to actually recoup air or energy in air by basically pushing air through a mechanism, a series of like intertwined metal straws or ceramic filter where you basically capture the energy that is leaving the building and put it back on the incoming flow. The final issue is light. We have free light that we get over the course of the year, but way too much in the summer and never enough in the winter. So how through design do you achieve that? And we can kind of flip through the next 4 because I covered them all there. And yep, keep going. And one more and one more. So one of the selling points that I've put for Passivhaus in the past is that it is simple and verifiable. LEED, I will give tons of credit for raising green building and best practices, but really that's what it is. Most of the things that we do in LEED were practices that we should have just adopted and filed anyway. We work our way down the checklist and we're done. One of the other things that I do think is important is, say, the bias towards urban buildings. But just because you build an urban building doesn't necessarily mean you should ease up on the balance of the best practices. My other kind of early complaint of LEED was the fact that energy was always the hardest, at least with the way that we traditionally build buildings, the hardest target to achieve. What I liked about Passivhaus from the get-go, it is a modeled solution as opposed to a checklist. You are actually paying attention to how what you design interacts with the environment around it, and then it's verified. So you have third-party inspections to make sure that you are building appropriately, and then you have an air tightness that is far beyond code. It's that 0.6 ACH, so that is a blower door run both ways to ensure that the envelope is airtight to something kind of far beyond what most buildings do or achieve. But that airtightness really is kind of the secret. That deals with water, that deals with durability, that deals with indoor air pollution, it deals with energy. If there's anything that would drastically improve our built environment, it is dealing with that airtightness and ventilation. It's often 30 to 40% of energy use. So teams, to Shane's credit, he went all around and picked and plucked the best people, and really one of the best teams I've ever worked with from around the country. It is an incredibly integrated approach. There are leaders in their field throughout, but from the very beginning, even in entitlement, we had, say, management company who's going to operate the building, plus the verifier who's going to inspect the building, plus the MEP structural contractor in a truly integrated design format. And the idea too is that even though all of these people are leaders, I guarantee you we have all learned from each other. Redwood Energy there, I just pull out. That is a net zero energy specialist from Northern California who I would not have met had I not been involved in these. And we go back and forth all the time. We disagree. We have different approaches, but we all learn from each other. And I think that actually gets to the end. Also, because it's worked out, it is risk mitigation because you have all of these experts in their field bringing their experiences and what has not worked and learning from each other. Next.
Yep, and that's a really important part. I think that another just sort of hidden challenge of COVID, right, is that we didn't have some of these conferences and some of the elements that we learned about here, right, to our direction to use ducted, for example, air conditioning instead of ductless air conditioning. Grew out of tours I did of buildings, people I spoke to who were building high performance buildings. And I think it's just a loss, unfortunately, during COVID to not be able to have some of these conferences and speak to folks and learn. Brandon, I guess I'll take next one. Like we really rely on a process and we have this idea, test, refine, idea, test, refine. We're known to have, unfortunately, for some folks, considered epically long meetings, particularly at the early phases when we were going through different methodologies or shapes or systems, and really trying to get all of the information out as early as we can and really think it through as deeply as we could into the process. It is one of my biggest pet peeves to be in a building looking up, for example, at a conflict where it's something that, man, like if we had just thought about that in advance, we would have addressed this differently. I don't like being in the building resolving. That'll always happen to some degree, but so much I think can be addressed if we spend a lot more time as a design team earlier trying to think through. It's never, and it's also it's always, I'll say, at intersections. It's never usually in the field of a system or a material that you see the failure. It is how a system interacts with another system. It's at a joint. It's at a change in plane. It's at a change in elevation. There's some change that happens, and to think through how the systems interact with each other. And again, we just think it's a lot easier to hit the delete key than to use that jackhammer or a crowbar. But we have to keep the process moving forward. It was my cousin, Jeremy Duffie, who always tells me, as I'm trying to constantly iterate the next best alternative, that at a certain point, we build the best building we can with the information we had at that time, and we move forward. I mentioned earlier, we try to keep the process, the systems as simple as we can. Complex is difficult to implement and install. Installation and installation professionals are seemingly increasingly difficult to come by. It's why you see such a drive towards systems built. We have complex is difficult to operate properly and difficult to maintain properly. So simple is just basically more likely to work over the long term, and that's what our partnership is about. So the next element is cost as a value, not just as first cost. This is one of the biggest obstacles I think that we see to the implementation more broadly, is that we think we have to start thinking more holistically. Systems are related. Most of what we're doing really is about improving net operating income, NOI. Utility cost reduction do that, higher rents increase NOI. They're on different sides, right, of the ledger, one's the income side and the expense side, but most of what we do impacts it, but some of it's a little bit fuzzy in exactly how. How do you value increased comfort? How do you value durability and resiliency? We are confident that there are values to them, and because of that, we proceed in these directions, knowing that having owned buildings for many years, I could see these benefits, but we have to start focusing on that long term and making appropriate investments. Uh, and that's why we think this works for any developer. I mean, I've demonstrated on my last projects that they're always positive on a financial, from a financial perspective versus having built to code minimum. I would say the Duffie companies, we don't build code minimum buildings. And yet it still seems like a lot of folks are reluctant to make that jump. We think that we have to start educating, and I think that it's already starting to happen. The consumer population, right, our occupants, our residents, and to not only focus on things like granite countertops and stainless steel appliances, that we have to make choices in how we're building. We can choose to do things like granite and stainless, or we can start choosing to start focusing and placing a value on high performance features or on comfort or on health. And that is one of the things I think that we have done successfully, or we did at the Duffie companies. And what I hope to continue to do with PS is to try to bring what we're doing down to the real life of the occupants of the building and say that air seal, yes, air seal is good for energy, but it's also good for addressing transmission of noise, which is a top complaint among multifamily dwellers, or odors, another complaint, particularly with the advent of things like legalization of marijuana. I've had friends who have complained that, you know, if they're living in places that they just cannot keep the odors out. And so some of the things that we're doing for high performance, as Brandon mentioned, air sealing is paramount, really have benefits that cross lots of different areas, including some that are really impactful to folks who are living in these homes. And with that, we'll go over sort of now the meat and potatoes of how we're trying to achieve what we're trying to achieve. Brandon, you want to run through our overall design approach?
Yeah, so back to what Shane said very early on, the iteration and the simplification was key to this project from the very beginning. And we'll get into kind of a bit of each of these in depth, but these would be kind of, I'll say, the divergence from kind of a standard approach, meaning the basic structure, we went with a panelized steel system that we will get into. HVAC, we have an approach where we look at either individual neighborhood or whole building approaches. And where we landed on this project was this kind of individual control, just a super simple ventilation or conditioning strategy. Ventilation, we can kind of pick and choose, so that we actually realized for this project in particular that a neighborhood made sense. So where conditioning might be controlled independent or into a unit, ventilation and dehumidification could be handled by clustering groups of units onto one unit in order to get the maximum efficiency. Water heaters, you know, we had a lot of debate about system-wide versus one-to-one and landed on individual and shared heat pumps. Appliances, that's kind of like the plug load, really, like what are you putting into this? And the highlights on those, it's really kind of a spec decision. But by using heat pump hot dryers, we were able to eliminate ducts, actually get savings. These are not condensing dryers. These are hot heat pump dryers that basically the only byproduct is water going down into a condensate drain. Induction ranges were there from the beginning, but one of the things that stayed true because of the smell and the order and the quality was actually working to ensure that we had range hoods. Refrigerators, that's just once again a spec. And then renewables. This project, more than any I've ever worked on, has really committed to incredible amounts of solar, with roof areas pretty much being dedicated towards one building. But as the project continued, one of the interesting things that happened was we were trying to figure out how to screen the garage to deal with planning review. And it turned out one of the cheapest things we could do was actually clad the garage in structure, cheaper than just about anything else we could do. So we ended up doing the very unintuitive thing of cladding the north face of the garage with solar panels. It faces off to the northwest. At first, we thought about using used solar panels to achieve it. Then we threw it in the NREL calculator, and it turned out we could get 30 to 35% energy production out of it. So once again, with iteration over time, we landed on actually a very functional, practical scheme that when you look at it as an outsider may never make sense. Who puts solar panels on the north side of a vertical garage? But the fact that it could continue to iterate, offer inexpensive solution, and then also tell the story. Anybody who's in the plaza or the retailer or part of the project, this is going to be the backdrop of that public space, is these kind of solar panel columns that kind of go up and down. And then even the canopy carries beyond. But as like I mentioned, when we started to really kind of engage solar and get down to full calcs, we are even overshooting our initial goals. Going back in where we landed on structure, keep it simple. I think Shane's kind of approach of moving to something manufactured led us to consider a whole bunch of different things. But where we ended up on was precast, or I guess a pre-manufactured structural system called Prescient. This was not in the project to begin with, but it is a 12-story panelized system out of Colorado originally, but now has a North Carolina facility. But this comes back to durability, speed. This is something which is machined. It is precise to within about 1/16 of an inch. It does have vulnerabilities, but very early on, we paired it with traditional conventional leaves. And by that, I do not mean the 1 inch of blue board tacked on the outside of a wood frame building like we do in the US. This is all the insulation being on the outside, done in a similar manner to how they would have done it in Europe. And back to trading value, as Shane talked about earlier, it turns out this was the least expensive way to get the building clad and insulated, coming in far below any other cladding we could have put on price, and taking care of the insulation all at one time.
And I'll point out that, Brandon, sorry to interrupt, but you mentioned that there are some idiosyncrasies to the building. I'm not sure that there are sort of vulnerabilities in it, but the idiosyncrasies of the system, and again, a reason to research them early. So Prescient works on a 2-foot grid, and Prescient likes rectilinear. They don't like curved walls. They don't like strangely angled walls. There's certain span limitations.
Yep.
And so when you sort of are thinking about why aren't you seeing, why do we not see more proprietary systems like this? Well, sometimes they're perceived as higher risk. In this case, there are I think millions of feet of Prescient out there, but I think that there's an incompatibility with the way that most projects in the United States come to fruition. Namely that you have an owner who hires an architect to design a building, who then hands the plans once designed to a general contractor, who goes out and bids the building to subcontractors. One of those subcontractors would be the framing subcontractor, in this case, Prescient. You would go to Prescient and you would ask for them to bid on your previously designed building. And they would come back to you and say, yes, we can design to your standards. So they can design to anything, but you're not on a 2-foot grid. So can you slide that wall over 6 inches? Can you take that curve out of the wall here? Can you change this span to the, and I can suspect that many of you are architects on this call are knowing how well that message is received as it comes from the sub to the GC, back up the pike. And then you just don't build it. And what we did is we did all this research early and tried to identify the system, learned its idiosyncrasies, designed around them. We really worked. We flew to Colorado. We toured projects. We sat down in a hotel room pre-COVID with their designers. We worked out, we asked to see their prescient unit library instead of us developing them, like what can we see, elements we would like, and we took advantage of the system that existed to try to optimize to this building.
And to carry that a step further, I mean, literally unit plans were designed at schematic design down to mechanical, which I think to Shane's point, that is a very early intense design process and not typical, but it enables it to happen. And then even as we've been learning it, we're perpetually learning more ways to get their system to be to perform better. And actually, I think one comment that came back when we were done was that we had followed the rules to the T, that we actually had the least number of posts per square foot of any project
That's
they
right.
had. They couldn't quite figure out why, but then they realized it was because we didn't violate any of the rules. We took everything that they told us to heart. We embedded it within our Revit model to begin with. We only have, 7 or 8 total unit types across the project, maybe 10. It just kept it incredibly simple, and not having a lot of modulation or a lot of thermal breaks or a lot of overheads. Or if you're doing it, do it with a reason and calculate it earlier. So our brows, we figured out the structural system, how to kind of cantilever back in and deal with the thermal protection of that. Or decks, we originally had a bunch of brise soleils that were eventually removed through glass tuning in order to minimize our thermal breaks. And the incorporation of them very early in the process is what enabled that to occur.
Great. So the next element was water heating. Right. So the major considerations is that we're trying to build an all electric building. We're not trying to bring combustibles here. So that meant electric, and that meant heat pumps both for units, but also for hot water. And we had to evaluate whether we were going to use a centralized system, semi-decentralized, individual. We had to consider things like accessibility for maintenance. The heat pump hot water heaters, also we had to recognize that they are effectively air conditioners, providing supplemental cooling and dehumidification, and how could we take advantage of that or address it. Keeping in mind floor area requirements, who would be paying for utilities. We're actually going with a split utility approach here. The age restricted building, which is 2/3 affordable housing, the 155 units, that building, they're actually most or about half of those units are sharing water heaters amongst units, one water heater to 2 units, and therefore that building is actually also all utilities included. That has to do partly with the master meter approach to get to zero net energy on a single meter using all of that solar. So you can see all of these systems had to sort of understand what the idiosyncrasies were and try to keep it simple in lots of ways. A single master meter with all the utilities going to the solar energy going to it was simplest. We don't have virtual net metering in Maryland at this point. And so this was one of the decisions that we reached, was to basically go with a hot air source heat pump water heater in a semi-decentralized implementation.
And I mean, to even carry that a step further, we have cooling and dehumidification need because of being in DC and Maryland. It's the buildings tend to have far more cooling need than they have heating need. So we were able to take the byproduct of the hot water and have that actually work towards meeting kind of one of our other demands. But then we also realized we needed to get like a little bit more energy in the building to offset the air conditioning that we're now providing through the heat pump hot waters. So then at the end of the corridors, we started tuning up our glass to actually get more heat in to actually help offset some of the air conditioning. And back to when you have a good MEP and early modeling, you can really be trying to get these systems to play off each other and take what would otherwise be a waste and have it kind of meet to the overall performance goals of the project.
And also knowing that passive house buildings the first generation, particularly some of the passive house buildings had a reputation for being a little warmer than might be comfortable. So again, we have this byproduct of cooling and dehumidification in a building that can tend to overheat. And we're not supplying extra heat by running hot water lines or refrigerant lines for that matter that might be rejecting heat, but still transmitting that energy through the building. We're not trying to dump extra heat throughout the building using a more central system. It's one of the benefits of not going to a central system. So we end up
And
with short pump pipe runs to avoid pump energy, and we avoid bleeding off energy into the whole building.
And absolutely. It's a cold water distribution system only, so it also reduces upfront material used. And even to the point where we even did pipe reduction sizes in order to increase speed, pressure, and reduce consumption from the hot water to the destination.
And I show some of these others like the Sandin, because I think that these separate condenser units separate from the tanks is sort of an intriguing direction that the market is going. But in our application, our basis of design is a traditional air source heat pump hot water heater, an 80-gallon tank serving when we have 2 units, and smaller tanks when we're on an individual. HVAC. Again, considerations trying to be all electric. We had to decide central versus individual, accessibility for maintenance. How do we get to filters? Utility cost capture for billing. I know that some of the VRF systems have the ability to measure refrigerant and pass that, but that's not so simple. Or is it well implemented often? And so we learned again that passive house structures can tend to overheat. Cooling's important. Most systems are oversized for minimal loads. Beware of short cycling. This is still one that we're working with Mitsubishi on to try to keep the system sizes down. That's one of the reasons also we hope there's a benefit of a ducted system versus the ductless system, where we have that one unit that powers the entire unit rather than having to put multiple heads and getting even worse. We don't want to rely on that single point of HVAC for delivery. And a lesson learned, and I heard it loud and clear when I toured a building in Boston, a passive house building up there, spoke to the owner. And again, mixing, just expecting, particularly when the mixing is of cold air, when you're supplying cold air, doesn't seem to be that effective. Central systems often come with significant costs. Central systems are more costly to install. Again, we had Bozzuto Construction in our case providing pre-construction services, and we had a large shred at one point, and the question came out, well, what's the cost of that VRF system relative to a simple ducted one-to-one? And it was materially less. It was something like $15,000. I mean, it was something crazy. They were seeing the VRF systems by the time they implemented them in high-rise buildings just be exorbitantly expensive and difficult to get dialed in. And so where did, also I'll just finish these out, that central system also, when you put that big unit up on the roof and carry the refrigerant lines down, you're not changing that big central system anytime soon. And so as the individual air handlers in the units fail, you're really tied to the system up on the roof. And so you're going to be keeping that same system, as opposed to our approach, right, with it is an individual ducted heat pump. As these duct and heat pump systems, which are coming down in price and up in efficiency all the time, if they fail, we replace that one system. We did not place a value on being able to control, although I think we will ultimately be able to, the individual systems. We want to monitor heat and humidity from these systems, but not necessarily the complexity of a whole building control system. And so we went with this very simplistic, up in the ceiling, ducted system.
And then the next challenge is actually, where do you put the compressor? Because there's also compressor lengths. And
Right.
the final solution to that, the most cost effective we found, was to actually provide a deck on the outside of the building where we could mount the condenser right in front of the unit. But then we took it even a step further, because these are now such low sown units, and this is actually a fairly noisy site, that we ended up stacking 2 small condensers on top of each other in a fin that runs up the side of the deck. The deck itself, we were able to eventually find a pre-manufactured unit out of Washington, where they're just building us the receiving cage to be able to stack those 2 very small condensers on top of each other.
And again, that is a great example of why you typically don't see it. Now, I joke with the team In Asia, you see a lot of first of all the home shows you see anywhere for house hunters worldwide. You see either ducted, mostly a ductless units up on the walls. But in Asia, I have these great pictures of just walls of condensers on the exterior. But the architects assure me I cannot get away with
I,
doing that
I
here.
guarantee you will not make it through park and planning with us.
Right. So
But
I said we could paint them a color, we could turn it into a feature, we could do something. But the answer was ultimately a balance of hiding them in plain sight, if you will. But of course, they have limited duct lengths, and that's why you don't see a lot of these smaller systems. Yes, it's more condensers. It's not more air handlers. We have the same number of air handlers we would have had with the VRF system. It's more condensers, but they're very easily accessible right on a balcony, and they're very affordable, and almost anybody can work on them. And so that's the key here, was trying to be able to implement through an architectural solution this mechanical solution.
and anytime you need to get at them, you can walk out on the deck, remove a panel, and you have two condensers right in front of you that you can access without scaffolding, without lifts, without a crane. Like, it is incredibly easy to maintain. Now, that takes care of conditioning. Now, ventilation. Same thing. We've done a whole variety of individual unit solutions, neighborhood solutions, where you deal with a cluster of units or whole building. The whole building, there's a lot of drawbacks when you get to high rises. There's pressure differential issues, there's fire dampers, there's a whole bunch of other stack effect come into play. Horizontal, we've actually found works quite well. If you can gather a floor of units, run ducts down the hall, it's a good, efficient way to do it. Another requirement for the project too was kitchen exhaust hoods. And so how do you actually deal with makeup air if you have kitchen exhaust ventilation? What we have worked through is with Swagon is the ability to put a unit down the hall that will serve anywhere between 14 to 20 units. And it runs back to a central unit that then, reaches to the exterior wall in order to get supply and
Yeah, these pictures are old. We're using a larger system ultimately than these. We ended up with working through with the electrical side that we were running at higher voltage, which was only for the larger units. So we ended up combining two of our neighborhoods stacked vertically.
And it'll say, though, back to just the iteration, we have a huge resilience goal for this project because we have the electrical engineer, resilience, solar, mechanical, Passivhaus, all integrating. 2 years ago, we came up with the 1 unit per 1 floor works great. We came up with a mechanical room that works great. We had line sets worked out, and we were setting off to the races. Then resiliency comes in, and all of a sudden it makes more sense to run the things at 440 or 480. That makes sense to upsize. And then we didn't really want to add dampers. Well, next thing you know, the team made a last minute move to do 1 unit every other floor and create small vertical neighborhoods where, we're not creating a bunch of vertical ducts or complexity or fire damping, but we are taking almost twice as many units as we had in our first pass. And I think with the way that the team works, we were very quickly able to run that through contractor pricing, supplier, mechanical, and then electrical cost benefit analysis. And I think in the end, with the way these systems work, we run them down the hall, then we have branches that come off to supply and exhaust. But then we also worked out that we can go unbalanced ventilation when the kitchen rain hood kicks on. It'll not drastically reduce the efficiency of the system. And it's not that kitchen range hoods are used, if every unit used it all the time, yes, it would destroy the efficiency of it for the moment that event's occurring. So yes, Thanksgiving Day, our ERV is probably not working as well as it could, but the other 99.9% of the time, it's going to be within, a couple percent and more or less kind of meeting standard efficiency, despite that unbalance occurred.
We did get a question again. I'll clarify. We are not using these smaller ducted units.
No.
We're going take this more for the approach that you see on the left here in the bottom of a branch that comes down, supplying the bedrooms, exhausting really from the bathrooms. The kitchen has its own exhaust, and then we ended up with larger units in a much larger space. I apologize.
We're using the Swagon Gold, which is, if for those of you who are not familiar with, it is a good European model that is available and UL listed in North America. It comes in a variety of sizes, but you normally don't touch it unless you're doing about, I'd say 12 to 20 units minimum on it.
And again, I'll point out again, because I think it's one of the things I'm proud of that we're trying with this is that we're putting those Swigon units on the emergency generator. So
Yeah.
Brandon sort of talking about when you switch to the higher voltages, because we have, we have a generator, a certain load. And so we built these very tight buildings. And we know that there are folks who always comment on, are we building it too tight? And the answer is always, build tight and ventilate right. Well, we want to be able to ventilate in all conditions. And so we are putting these ventilation systems on the emergency generator. And what we see, from what just happened in Texas, a lot of folks got really uncomfortable really fast. And with us building a passive house structure as well insulated and air sealed as it is, and providing ventilation, not just ventilation to bring in that freezing cold air, but ventilation with heat recovery, we're really trying to aim to create an environment that can be maintained livable in the event of an outage, and that's resiliency.
Yeah, and to take that a step further, the conditioning dehumidification, there's a module that's actually tied to that unit that will also be powered as part of that. So if there's a hurricane or a blizzard, what that does is you might not have individual control, meaning you might not be able to get that temperature exactly where you want it during there. But overall, you're going to be within the typical comfort constraints of a passive house build because there is going to be that dehumidification, that cooling or heating, depending on the season, that will run through. Yeah.
And again, and then again, resiliency and sustainability. We're putting renewables on. We're putting quite a bit of renewable energy on the building. I pulled over the image to see we've got a parking garage that faces south, adjacent to a very heavily trafficked Capital Beltway, the ring highway, as we know, around Washington. So 200,000+ vehicles pre-COVID, rapidly, if not already there, back to that level of traffic. And also what we're doing is, and this is an older, again, image, but we're basically dedicating all the energy from the site and the garage to the single building. So people hear we're trying to build a 12-story zero net energy building. Yes, we know typically, we could produce as much energy on one roof for far fewer than 12 levels, but we're not using just our roof. We're using the energy available on the garage's roof, on the vertical face of the garage, on the north face even of the garage. And to the degree we need it, which we don't, we could use the other building. And in this way, the entire project is supporting the age-restricted building. We had a choice. We did not have enough energy production to achieve zero net energy on both buildings. And what we chose, therefore, was to dedicate all the energy to one building to achieve zero net energy on that building. And we think that that's going to yield better results. And also from a wiring perspective, that's a simpler solution. And it's the direction that we've chosen to go. Again, we're happy to have the project in Montgomery County in partnership with HOC. Montgomery County has a new Thrive 2050 plan for those of you familiar working in this area. And we think that the project really just fits right in. There's not going to be one silver bullet for what types of buildings need to be in the future. It's going to be several, but clearly projects like Hillandale Gateway are one of the building types that are needed. Montgomery County also has a climate action plan. Here you see starting in 2030, zero energy building code. They want to aspire to be zero net energy by 2030. Here you can see we're a decade, ahead. We're trying to build zero net energy and demonstrate how it can be done, at as close to parity as we can from the beginning here in 2021, starting construction in 22, not in the 2030s. And we're really proud to be working on the project together with HOC. I'm thrilled to be able to work with Brandon, and I've learned so much from Brandon in this process. And that is Hillandale Gateway. I can pull open the model. If anyone has any questions, we can do it in the context of this model. But again, it's a two-building program. There's the age-restricted building, 155 units. There's the non-age restricted building, 308 units with a couple retail pads in the front, connected by a garage. The buildings are actually offset one level. The NAR is half a level below the AR building. This is the north face. The south face faces the Capital Beltway. Here you see we even have a solar canopy on top of a play area on the ground because the volumes of the traffic was relatively high, and we just put a shield up. The site is very tight, and we wanted to really utilize any space that we had. Here you can see those fins that are hiding those condensers. And so while there are 2 condensers in each of here serving the end unit and the unit adjacent, if we zoom in, you can kind of see those Passivhaus sort of tilt turn windows with 1 operable pane, rooftop amenity space. Again, sound attenuation noise attenuation was a requirement through the planning process. So we came up with this strategy of the parapet wall with the glass behind it, partly again for maintenance, right? We try to think things through. If we put the glass out on the edge, how are we going to maintain it? So we put a doorway through, we can come in, clean the glass, and try to basically keep our building in good condition for many years. There'll be an indoor swimming pool inside the NAR.
Now we didn't even touch, but that we're actually designing within the Passivhaus envelope using kind of the same concept. You build a thermos, it goes to a temperature, you set that temperature, it wants to stay there. So the biggest kind of energy use of that pool is just getting it at temperature the first time, with the goal of then just kind of maintaining it and actually air sealing and separating it from the balance of the building on separate mechanical with a defined zone.
We really tried to think through function of the site and loading and unloading, so there's integral loading. Yes, Ben.
While you're talking through this, if folks want to type in questions, that's great. We can also,
I was going to say there's 19 of us. You could unmute and we could have a conversation too.
Yeah. But we have a question out there. The pool just brought up a whole lot of questions for me, but I'll come back to that if we have time. Did designing to pre-essence modules and rules make it harder for other subs to compete in price during bidding? How much extra time did it take to go through the process of learning the pre-essence system well enough to design with it in mind?
Yeah, so the prescient system was designed before it really even got to that subcontractor pricing. It's this basic, it's a mid-grade steel frame. So there's a metal post. So it's the same in terms of running wire, running plumbing. It's the same as any commercial cold rolled, metal stud system. So we don't think there's going to be any pushback necessarily on that type of system once we get it out there. We didn't hear any negativity through Bozzuto while they put it out for preliminary pricing to different folks. In fact, I think what it does is we can avoid conflicts, and so we could pull up, like, they model every stud, right? We can see where everything is and help provide clear guidance, and did work out some of those things earlier. It definitely takes more time to program to the rules, and I think it takes as much time as you're willing sort of to give it to design to the best of your ability. So I mean, I don't know how, as a percent or hours, Brandon, maybe you could say how much.
Well, I was going to say is, I think what really made this project work from a design side was the fact that we knew fairly early on in the entitlement process that we were heading towards prescient to get height. Once we knew that, I think you've seen a couple earlier versions of the projects that used to have more angles, were a little bit more low rise, a little bit more spread out. There was an epiphany in the middle of entitlement that what we wanted to do was to actually go vertical. And actually, one thing Shane didn't cover was that retail pad is actually preserved as a potential hotel or office building in the future. There's an ability that you could remove those 2 retails and put another 7 or 8 story building in the middle of the site if it ever became economically viable. The other thing is we realized prescient prices closer to wood than it does to type 1 concrete. So we went to maximizing prescient everywhere we could, trying to get it up to 12 stories, bearing slab on grade wherever possible, and then only doing raised podium decks over amenity or retail space. So once we understood those rules, we actually reconfigured the site in entitlement to be able to do it. But we always knew we could come back and do a type 1 building. We always knew that we could come back and alter to another light gauge manufacturer. Their price has gone up, but it is.
So is wood.
Yeah, so is wood. It's continuing to make sense.
Yeah, and so that's a key point, though, is that we chose a proprietary system, and we said early on, we can build a building designed to the prescient rules in anything. We could build that plate in wood, we could build it in concrete, we could build it in metal, we could build it anything. But you cannot build a building designed for anything in prescient.
Yeah.
And so we didn't remain beholden to prescient, if you will, as a proprietary system when we made the decision to design to those rules. We just knew that we were building to optimize to that. And so as prescient system, like everyone else has come up, we've constantly been asking Bozzuto to look at it. You know, does it still make sense? Does it still make sense? And it has continued to make sense.
And even from the beginning, like we integrated, like we worked through the deck details with them very early. That said, we ended up kind of modifying that over time as their system progressed. I would say actually the biggest issue that we knew to deal with early on was just shear wall integration. They do have a shear panel they use occasionally, and we just let our window modulation, I hate to say, move or place around that requirement. It's not every bay. You know, I'm looking at kind of that, the NAR you can see in the distance here. You can see the two decks kind of right facing front, and there's a panel that's just slightly wider in between those two decks. You barely even notice it, but you can see that the corner panel, that mid panel between the two decks, and then that panel in between the next two decks. It's very, very subtle. You wouldn't know that it was there, but knowing that they had the rule that they needed essentially an L in the exterior facade about every third unit, great. We have an L in the facade every third unit, and that affects our retail glazing, that affects the glazing above. And I don't even know if Shane even know we went through that coordination, because, you know, it was one of those rules we learned very early on, and we're like, we can follow that as long as we know it's there. Because of that, we've had very little modification as we've continued to develop. I will say the danger with prescient is they're so fast, and on top of it, they have a crew of engineers and CAD designers in Poland. And so we are always behind them. I mean, it just, any change that we do, it'll take, 24, 48 hours to get it integrated into Revit. They're on it overnight and have it back to you by the next day. So I would say they actually have a very strong engineering team. They have a very good production team. The only caveat I'd put is they do have some communication issues between bidding and design, but that's minor. That's something you can get past. And I've actually found them very pleasurable to work with. Now, Shane brought it up. I'd bring up the Revit model, except Shane, what I originally realized that part of the reason it takes so long to process is you really do have to peel back what you show, because they model everything down to the bolt in, say, an expansion joint in the full model. Every stud, every I-beam, everything is there. They also do run clash protection. So like one of the things is we were just doing a bunch of land use coordination. We had a call today. Torty Gallus, who's actually been a great partner who we work with in the DC area, some intern had moved 24 windows and now affect their windows. They can tell us, like, you need to go look at these stacks. We think we have a conflict. They're very, very thorough at what they do.
Yep.
It's a great question in the chat from George about how the balconies are structured. You said balconies, and I was thinking passive house penetrations.
Yes, there is a passive house
How
penetration.
Yeah.
So there is a bit of kind of armatherm or high density generic plastic in between. We worked it through with them early. Their details have changed, and then we morphed with their change. But we have two outriggers that are going to be provided by Prescient that hold up their standard deck that stick about 6 feet off the face of the building. Onto that is going to be put a aluminum pre-manufactured deck with a rail system. And then onto that is actually where the condensers go, and then that goes back into the wall. So, the picture Prescient's going to go up first. The outriggers and the extensions are going to go on that first pass. Stowe is going to come in, or EFIS is going to come in. They're going to apply the EFIS skin to the whole building. There'll be sleeves to receive the line, and there'll be two outriggers ready to receive the deck. The deck will go right down on the outriggers, really conceal the outriggers. And then the rail goes up. And so it is very repetitive system. I mean, my joke is the only deck that we don't comply with that on is we do use the prescient standard deck on the corner of the AR building where we wanted a continuous deck. So there we do have a series of outriggers and a series of thermal breaks.
Got it. Would anyone else like to unmute and ask questions? I'm gonna give that like 20 seconds. The mute button is bottom left of your screen, or if you're called in, we don't actually have anybody just called in, so we don't need to give you the hashtag numbers.
Yeah.
Alrighty. So I'm going to ask a question about the pool, and then if nobody else has questions, we're going to call it a day. So pool in a passive house, you've got, you know, for energy code, you'd be doing energy recovery on the water heating side of the pool. So basically,
so
you know, air leaving the pool would have to heat the water of the pool. How do you actually
I'll take
balance
this
that
step.
if you've got that strong of an envelope?
So so step back. So the biggest problem with pools is two things: evaporation and contact with the ground, right? The way Passive House approaches a pool is you actually treat it like a thermos, like anything else, and then it has a different set temperature point. So if you get to the pool area, that is air sealed, modeled separately. We've actually modeled it both in PHPP and Woofy Passive. There's an insulated crawl space, for a better word, vault around the pool. So there's an equivalent envelope below the pool and through the pool. And there should be a line on those drawings. Oh, you probably don't have the set with them in. There's a line where the pool mechanical is in on the pool envelope side. That stair is actually general conditioned, and then it comes down by the changing rooms. So that whole pool area is essentially a separate air volume from the rest of the building, air sealed from the rest of the building, mechanically isolated from the rest of the building. The pool water itself, the goal is to bring pool water up to temperature, but then you're not going to have those ground contact losses. Then the air is actually set to 85 degrees, the same as the pool water temperature. And that does help reduce evaporation and moisture losses. And then there is a dedicated ERV that runs that pool space. And then the pool water, this is not natural gas, so it's, you know, electrically heated. So the big expense is bringing it up to temperature the first time. And then that actually, the pool, the pipes and everything are within that same temperature space and are going to be run at that same temperature. So picture it like, instead of doing like, you know, an in-ground pool where you've got 57-degree earth contacting your 85-degree pool water that's perpetually leaching your energy away. You've got an insulated envelope and an air-sealed envelope all the way around that, and it's just run at a different set point. Does that answer your question?
It does. That's fantastic.
Yeah, I'll thank the Germans. To Shane's question, this is why over the last decade I've spent so much time focusing actually on my direct relationships with architecture firms and passive house specialists in Belgium and in Germany. Particularly in Brussels, there are two firms that have developed a pretty good relationship. We've actually hosted them over here. This is Sabine. She was the one who taught me this. She's with Architect Associates in Brussels. They did a retrofit community center. And she walked me through, actually before this project, for another project we were working on, consulting with how to do a pool in a community center. And back to, this stuff is not new. There's people who've done it. You just got to find them. Unfortunately, most often they're not in the United States. And once we kind of got the philosophy, we realized it's no different than anything else. We're really just changing the modeling parameters, which the model's set to do anyway. You can crack the model open and change your ranges anytime. It's designed to do that, and the physics does not change. So.
Alrighty, gonna open it up one more time for the audience and unmute yourself if you're looking for it. Alexis, you just unmuted.
Yes. First of all, that pool thing is so interesting to me because my parents have a pool and it will be hot on some days. The pool will still be so cold. So I just found that really interesting. Is that, and this is my question, but that works for outside pools too? That whole, yeah, because is this an indoor pool?
It's an indoor pool. And
Is it
actually, when we
safe?
started on the pool, when we started on this project, it was an outdoor pool. And I think I challenged Shane and Torty that if you put it outside, one, it's a huge energy loss or energy consumer, but you also might only get benefit of it, 10 or 12 weeks out of the year. And if it is in the envelope and it stays at temperature, you've now created something that's actually going to probably use less energy over the course of the year and as a year-round benefit.
But I
Okay,
think
okay.
also if the question is, does an outdoor pool suffer from the same heat loss associated with a 55-degree ground temperature? The answer would be yes.
Yes.
It
Mhm.
would, and therefore, insulating the pool, if you tend to heat your pool, probably insulating the pool in an outdoor environment would also provide benefits for the same reason, that heat's going to
Absolutely.
go from high to low. And if you have a 70 or 80-degree pool and the walls of the pool are always at 50 something degrees, you're always losing heat.
Yeah,
Okay.
and take that a step further. If you have an outdoor pool, 5 of your surfaces are to the earth, which is going to be 54 to 57 degrees. So you are perpetually losing more energy actually out of those 5 surfaces through earth contact than you probably are to the air in the summer.
Oh, okay. I have one more question. I'm not sure if I walked away and didn't hear if you already said this, but this whole idea of passive houses, is this new to the area, or is this like, are there other passive houses in like the DMV area, or is this completely new? Because I'm not sure.
So you want to take that one?
Yeah,
I'll
so
give you
I'll
my
say it's Passive House itself is not new. There
Mhm.
are buildings that are built to these standards and use the principles in other parts of the country, but in the Washington metropolitan area, there's, I think, one larger scale. It was a retrofit, Weinberg Commons. I don't know of any others, and even that's not at this scale. New York has been a front runner in adopting passive house principles and standards. So there are some buildings there in the Pacific Northwest where Brandon was working. There are some buildings out there. There are buildings built to passive house standard in Pennsylvania because there were some incentives provided through affordable housing, where ironically those initial developers saw a bunch of points that they would get for building a passive house and went after the points to win the awards without maybe fully understanding what was involved. But we've learned from those buildings too, and spoke to some of the professionals on those too. So
Yeah.
the answer is, in our Washington metropolitan area, there's nothing like this. And we hope that there will be more coming, but we think that passive house, the same way, again, we looked at LEED was coming, whether it's the adoption of passive house PHIUS or Passive House North America or other standards, PHI. I don't know, but I can tell you that these principles for how we build buildings, of air sealing, paying attention, that is coming in code. That is coming. So we can either figure out how we're going to do this stuff now, or it will be required of us in the future, the same way that we looked at LEED.
Take it as another way. You can either learn how to do this now, in which case you'll just be applying the requirements about, or you can struggle without having the ability or knowledge behind it to come up with different ways to do it when most of it's already been solved. I got into passive house in the Northwest. We actually did the first certified passive house in Seattle. That was back in like 2011, 2012. I first got into it about 2009. There's a market there, mainly just environmentally conscious developers who supported it. So there was a cluster there who started doing market rate projects, starting with houses, then townhouses, then apartments, then podium buildings, and it's just kind of naturally grown. Pennsylvania, to Shane's point, there's now a couple hundred buildings built to the standard in Pennsylvania, predominantly because of the low income tax credit. But then there's also a lot of just kind of naturally occurring civic projects. One of our projects was a library. We're working with a private school. There's university projects coming online. There's dorm projects coming. But yeah, the 2 largest places in North America right now are New York and Vancouver. And it's because in New York, it's essentially become code. And in Vancouver, if you want to build anything over 6 stories, you need incentives. The incentives require passive house Therefore, every developer builds to Passivhaus. On the naturally occurring side, I'd say probably the most interesting project is the MP Boston Tower, the Millennia Tower, that has got a huge, I think 750,000 square feet of Passivhaus space in it. And that's just a market rate high rise that's electing to head this way. So, yeah.
Thank you so much. I find this really interesting, by the way.
Absolutely. And I was going to say, if you want more information, the two best sites are the PHIUS website, that's Passivhaus Institute US, or the other one is the North American Passivhaus Network, or PHI. The German institute actually has an English-based website as well. And any of those three are really good resources.
Thank you.
All right. I think we're gonna close it there.
Yep.
Shane and Brandon, will you stick around for we need to redo your intro because I pressed record too late. And then and everybody else, I hope to see you next month at our July planning meeting. Thank you
for having us.
Yep, thanks.
So who's running the slides? I think Shane, you are. Would you mind queuing us back up and doing your first two slides again? And we'll edit it like nothing happened.
Very good.
We'll leave that up to you.
We'll take care of that. Thank you guys for doing that.
Okay. Good evening. My name is Shane Poland, and I'm principal with PS Ventures. Happy to be here this evening with Brandon Nicholson of NK Passive, and we're going to be walking through a case study of our exciting Hillandale Gateway Project, which is in the Hillandale area, or Silver Spring, Maryland, in Montgomery County. And this is largely a repeat of a conference session that we provided recently at the Montgomery County Energy Summit. So again, my name is Shane Poland, and I'm with PS Ventures, a real estate developer and owner. It really focused on a long-term approach. I spent 17 years working with family at the Duffie companies, developing primarily multifamily buildings in the Washington metropolitan area. And as long-term holders, really focused on quality and durability, because we were the ones who were going to be maintaining the building and paying for the building for a long time. I'm passionate about building science and building better buildings. And Brandon?
Hi, and thanks for having us again. I'm Brandon Nicholson with NK Passive. I'm an architect by training, but over the last 10 years have moved over to become much more of a Passivhaus specialist and executive design architect. I also have a real estate development practice where we develop and own and operate high performance buildings as well. And just excited to be here to present the project.
Awesome.
Great.
Thank you.
And good luck with your edit. I saw the recording pop up during my introduction, so it caught me hard.
Yeah,
So.
I know. Kathleen reminded me. I went, oh no.
No worries. At least it was in the first two slides.
Yeah.
Yes, exactly. Thank you both for doing this. Now, let me turn on my camera. Thank you both for doing this.
Absolutely.
I really appreciate it. That was, I'm a geeky engineer, so for me that was grand. And I also think you hit the right level of detail for a lot of folks to pick up some stuff.
Yeah, ooh, that's why we do it. So
Awesome.
hopefully they got something.
And Ben, hopefully, we are still in process with HOC, with the commission proposal. I hope to be able to reach out to you soon and have you even more involved, we hope, in the project. So
that would be grand if it goes, and if it doesn't, that's an okay thing too. Oh, Brandon, you're cracking me up. I lived in Seattle for 5 years, from 2008 to 2013, and then we moved to Baltimore.
Oh,
Most of
yeah.
my firm still sits in Seattle, so I was like, I know exactly what project he's talking about. That was a big splashy thing when it hit.
Yeah. No, it's funny. There are a lot of people who spent time in Seattle and then for various reasons their family ended up back out east.
Yeah,
Yeah,
this
Park
was
Passive.
a can't say no job for my wife. So
Yeah. No, Park Passive, it was very similar relationship with Shane, and we continue to do a lot with Cascade Build today. They have grown with us. They're currently wrapping up a 70 or 80 unit podium building that we designed out there. And then they've got another one coming behind that. So I hate to say, I try to keep out of the architecture now and just on the Passivhaus side with Sloan, but he is like a geeky developer contractor, and he's exactly like Shane. I think you guys have actually met at this point, but Sloan just likes the hacking and figuring it out and working it through and solving the problem. So
and that is fun.
yeah.
Well, thank you for
Very good.
inviting us, Ben.
Absolutely.
Thank you, Brandon, as
Yep,
always,
Shane.
for your partnership.
I was going to say, I think you're off tomorrow, so I'll catch up with you on Thursday.
I will.
Yeah.
Have a good one,
good night.
everyone.
Okay, bye-bye.
Thank you guys again.
Thank
Bye-bye.
you so much. Bye-bye.